Good afternoon and good evening, everyone. My name is Zhao Yang. Today I'm going to present a paper about the compound drought and heat waves in the northern China. So let's look at the overall of the poster of this paper. This is the poster I made for the paper. And so for the background, global warming has made droughts and heat waves worse. And when they happen together, the impacts are much more severe. So, but most studies so far have used the monthly data or focused on single events. So this paper uses daily data to get a more accurate picture, especially for northern China's semi-arid and semi-humid zones. And for the objectives, the objective is simple. It's just to track how these compounds events changed from 1980 to 2018, and to figure out what's driving them. And for the methodology they used for this paper, they used the daily SPI and temperature data. A drought day is when SPI drops below to 0 - 0.5. A heat wave day is when temperature goes above the 85th percentile. When both happen on the same day, there's compound events. They also classified events into three severity levels: moderate, severe, and extreme. Okay, so for the results and analysis here. Okay, for the results and analysis, the first figure, this figure, okay, this figure shows how the CDHE frequency changed between 1980 and the 2010th. The southern part of the region saw a huge increase, 20 to 50 times more event. The north also went up, about 10 to 30 times, but some central basins actually decreased. And over 80% of this whole study area was affected. And let's look at the picture below. The second figure shows annual duration. The area experienced more than 11 days of the CDH per year, went up from 28% in the 1980s to nearly 57% in 2010. So not only are these events more frequent, they are also lasting longer. And importantly, the analysis found that heat waves are the dominant driver, with correlation coefficients above 0.95. Drought, on the other hand, plays only a minor role. Okay, for the discussion part, the paper also gives a specific example: the Yellow River Basin. Average annual CDH duration there went from about 10 days in the 1980s to nearly 70 days in the 2010s. There's a big increase, and the pattern follows the heat waves much more closely and droughts, which confirms that the correlation analysis showed. So let's make a conclusion. First, both frequency and duration of the CDHE increased significantly from 1980s to 2018. Second, heat waves are the main driver, not droughts. Third, short duration events are becoming less common, and the peak timing has shifted from June towards July and August. And fourth, these findings provide useful information for climate adaptation planning, especially in vulnerable transition zones. Okay, the references listed here are the key sources cited in the original paper. I've included three of them at the bottom of this poster, and my contact details are also there if anyone wants to reach out for more information. Okay, so here's my contact. So let's make a summary of this paper. I think it's a valuable study for understanding how these compounds, droughts, and heat waves events are evolving in climate-sensitive regions. Thank you for listening. I'm happy to take any questions.